So in today's session, we are going to start with Docker. So what is Docker, why we need Docker, and why it's became very popular, that we are going to discuss. So before we are going to start Docker, we need to talk about some history. Okay. So in the initial days, like in maybe 1990, in that period, so what we used to have a machines, right? Only the CPU, RAM, the machines we used to have. And on top of that, we used to install the operating system and we make use it. Okay. And once technology revolution, okay, comes into the picture, like once software came into the picture, like a lot of things has been changed. Like for example, internet. So once internet started, so what is going to happen? Lot of web, like what we can do in the internet, we can able to access the websites. Okay. So with the websites, lot of companies can do business. So before internet, nothing was there. Like we used to have our independent machines, standalone machines, and we will install some personal softwares, okay, standalone applications, and we used to manage it. But once internet came into the picture, then we can able to access lot of websites, and those are called as a web applications. Okay. So during that time, to run that website, okay, it's a web application. What that web application might be running on some servers, and we can able to access them in the through the internet, right? So to run those servers in the background, to run that application on the servers, whoever is maintaining, whoever the owner of that website, okay, so they need to run some n number of servers depend upon how many users are accessing it. Okay, so they need to maintain some n number of servers. So what it contains, server means it will have CPU, RAM, and internal hard disk. It will be there, and we like if I am the owner of that application like website, then I'm going to deploy the applications on it. Okay, so the place where it is called as a data center, like I cannot keep all those machines inside my home, right? So we'll search for a place and we'll keep all those machines in one place, and that place is called as a data center. Like not only the servers need switches, routers, and internet connectivity. Okay, and to maintain the temperature, it should maintain air conditions should be there, so otherwise the machines will crash. So a lot of equipments, peripherals were needed to run that data center. So let's say initially, when the initial stage, when we launch that application, let's say uh, the application version is maybe 1.0. Okay, during that time I required only two servers. Assume this is in the period of 1999 or 1995, something like that. Okay, so then version, like my applications are upgrading. Okay, maybe I'm adding new features to my application. Like we see a lot of versions of the application, right? For example, in your all laptops you might be installed Java to run some Java application. So the Java also might be changing the versions, and it will recommend you whenever your laptop connect to the internet, it will ask you to upgrade the softwares. Even for in your mobile, whenever you connect for Wi-Fi, so it will ask you the recommended apps are going to be updated. So if I click yes, then it will update all the applications. Means back and it will change the versions. So what will contain the version change? Maybe some new features, or maybe to fix for any bugs and vulnerabilities. So when we are changing the versions, we may need a few more servers, because we are adding few features, okay, to our application. So two servers are not sufficient for that. We need to add few more servers. So then again, we'll add two more new servers. Maybe in the year like 1998, our application has been upgraded with new versions, and maybe in the version 3.0, we need 20 servers now. So when the features are changing, means users also increasing. So now we need 20 servers. So what we can do? So based upon our business is increasing, the servers counts also increase. Like for example, whenever we start, if we started Uber, then initially maybe very less users might be accessing the app to book the cab. But maybe slowly, once it is becoming famous, lot of users will try to access. When lot of users are trying to access, then the servers count should also increase because that much of traffic cannot able to handle very less servers. So the same manner we are going to increase our servers. So here the problem is if it is a startup company and I don't have enough budget to buy the 20 servers. Okay, so what are the budget I have? It is not sufficient to buy not only here 20 servers, along with this lot of other equipments you need to buy. As I mentioned, servers, switches, routers, or the resources should be increased. So the budget, whatever we have, it is not sufficient because we are like startup company, right? Okay, so for a startup company, it is not possible to uh, invest that much of money, not only for the servers, other devices also need to purchase along with the air condition. So during this time, so revolution like virtualization came into the picture. Okay, so what is virtualization? Till that time, we were using the physical machines, and inside the physical machines, everyone used to install the operating system. On top of that, application used to run. But in 2005, I think around 2004 or 2005, not sure exactly. So during this year, virtualization came into the picture. So what we can do with the virtualization? We can virtualize our environment. So taking one physical server, we can create multiple virtual servers inside one physical machine. So here I don't need to buy 20 servers. So I can buy only 5 servers, and inside that 5 servers, I can fully. And the advantage is when it is before virtualization, we might not using the full resources of our physical servers. Maybe one server might be using 60% of the CPU and 40% of the RAM, and another machine might be using 40% of CPU and less than 30 to 40% of CPU RAM. So lot of resources we are wasting. But once virtualization came in the picture, so we can able to utilize efficiently. Why? Because we can create a number of virtual machines inside this. So this will be the physical server, and this will be the operating system, and this will be the hypervisor we are going to use, and VMware and Hyper-V from the Microsoft. So these are the top companies who provides this virtualization software hypervisor. So here previously we used to install operating system, and top of that we can able to install hypervisor, and then we can create multiple virtual machines here. How much resources you want, based on that you can create them, and later on also we can able to increase the resources or decrease the resources. Maybe if I'm allocating for this machine 16 GB RAM, 8 CPU, then I can able to decrease also. If applications are not consuming the complete resources, we can decrease. Or if this machine is allocated with 8 CPUs and 8 GB RAM, and it's performing very slow because of the RAM is fully occupied, then we can increase the utilization. So here, whatever the resources contains this machine, we are going to use it in efficient way. No need to waste any resources. So and we don't need to buy the huge servers, physical servers. We can reduce the space. So this way, virtualization came into the picture, and lot of companies, not only the startup company, it helped a lot for the existing data centers who were having very huge large scale of servers. They are also started migrating their applications to run on the virtual machines. Okay, so this way it will help a lot, and even for startup companies also it will helpful. And this is also advantages virtualization was providing to run it on your local laptop also, like VMware is having VMware workstation, and you can able to install like Vagrant is also there. You can able to run on your local machine, and you can create multiple virtual machines if your laptop supports that feature. And we can able to create multiple virtual machines inside our local also. Okay, so now after this, now the company, even startup companies, like for buying these 5 servers also, for startup company again it will be a little bit burden, because maybe each server maybe cost around 3 to 4 lakhs, right? So again for startup company it will be a burden for to buy this much. Guys, please go on mute. So even for startup companies, this is also burden. Okay, because to buy this single server, it will be 3 to 4 lakhs of rupees, and to buy instead of 20, if they want to buy 4 to 5 servers, then still it costs around 15 to 20 lakhs, which they cannot afford. Scenario again from 2013 to actually AWS came in the 2006, but it's became popular from 2012 to 13. So cloud came into the picture. So what is cloud now? So cloud, no, you don't need to buy anything. You can just taking the machines as a rent basis, and whenever you don't need, again you can give it back, and you are going to pay monthly wise. So you don't need to have 20 lakhs with you, and you don't need to buy anything. You just take the servers as a rent basis and use it, and monthly you can pay some thousands of rupees because you are a startup company. So instead of investing lakhs of rupees initially, so it's better take machines as a rent, and then you can pay monthly wise. And if once it is clicked in the market and you are getting a lot of money from that business, then later on in the same cloud itself you can take for permanent. Like instead of taking rent, you can pay for complete 1 year. We call it as a reserved instance, and you can use it for your organization once your business is stable. Okay, so the once cloud came into the picture, again lot of changes, and it became revolution because every company is not every company, maximum 60% of the companies are migrating from their existing on premises, because most of the people were thinking, okay, virtualization came in the picture, they used to save a lot of money. But once cloud comes into the picture, so companies can save a lot of money, like licensing part, administration. Okay, if I have 500 servers, Linux servers, we should have at least 10 Linux resources, right? And to, to run the same, there will be database engineers will be there, monitoring team will be there, um, Windows teams will be there. Lot of infrastructure resources are required in the traditional data center. Once it is moved to the cloud, then no, we no need these many resources. Okay, very less resources. AWS administrator can manage database, Linux operating system, storage, backup, everything AWS engineer can take care. So lot of money we can save, and the main agenda of the application guys, like product companies, they can focus on their product instead of managing the infrastructure backend, right? So they can completely dedicatedly focus on their product. So if someone else is managing our infrastructure, we're just using it. So for startup companies and for their existing companies also, that is the reason they are migrating it to the cloud environment. Okay. So now in the cloud also, what we are going to do, we are going to uh, create virtual machines, and we are going to use it. We just connect it, and whenever we don't want, we can shut it down. So this is also good. Okay. So now what is the link between this? Why we need to discuss about the Docker, but why we are discussing about all these things? Okay. So here comes, see, whenever whether it's on virtual machines in the AWS or virtual machines on the VMware, or maybe when it was before, if you talk about physical machines. So basically what happens, whenever developer writes the code, okay, so what is going to do when the developers are developing, the development team is developing the application, what kind of application they're developing. Let's say if they're developing the web application. So if they're developing web application, they might use any language. Maybe if they are using Java or Python, they might be taking. So when they are using Java, they need some framework to develop the Java application. They need a framework called Java is having Spring framework. Okay, and Python is having um, Django. Okay, so framework they needed, and along with the framework they need some libraries. So before they're developing this application, they will do a lot of research, and then they will find out what libraries will suit it. And they need libraries, and some dependency softwares also is required. Okay, and some OS level features also required. Means some dependencies from OS level configuration settings might be, or some softwares also might be required. So to have this, what they are going to do, they will run all this inside the machine. on their local machine, and they will start developing the code. And okay, obviously we have source code management, that is later. So once they develop with the code, so what they are going to do, that application will be given to the testing team. So what testing team will do? Testing team need to do the testing. So this application is going to be given by these developers to the testing team guys. So testing team what need to do? They need to download the same framework and libraries and OS level features. So if they downloaded framework same, but if they download different versions, or libraries also they download but different version. Here it might be using a 1.7, and here they might be using, testing guys might be using different versions, and whatever the application is developed, it might not work properly. Okay, they might face issue again. They'll come back to the developers, and again they'll check the versions, everything. Again they will start using it. So once they do the testing, everything, once it is fine, then it will deploy onto some staging environment or pre-prod environment. So operations team will do the operations. Operations team means they will do the testing, like this is functional testing they'll do. Operations means in the pre-prod environment, they will check how it is functioning. Okay, I think most of you guys know about the difference between prod and the pre-prod. So pre-prod is like almost like prod, but there will not live connections will be there, but they'll try to check how, if it is a live connections, how it is functioning, everything they'll do here. And here the functional testing is what the logic is working or not, they are going to check it. Okay, whatever the customer requirement is there, whether as per the requirement, everything the logic is correct or not. And then it will go into the production. Okay, assume this is like a pre-prod. So again, when if it is running, so here again we need to manage everything. Okay, so same versions of libraries, same versions of dependencies, same version of Spring framework, and OS also. Okay, so here when the developers are working on their independent machine, they might be configured with the OS. Okay, some settings or maybe some software dependencies. So that should be same here. If that is not working here, maybe if it did not match, maybe for example, if it is a kernel version is different, and your kernel version was different, then the application might not function, because maybe there is an like this particular framework version or this particular library version will only work with this specific version of the OS. Okay, OS kernel version. Then here the versions has been changed. Maybe kernel version, little bit latest version has might be installed by the operations team, because operations team doesn't know. So they will just, if they tell 7 version is required, then they'll just install latest 7.6 for example. But this might be tested with 7.4, or might be 7.6. So again they might face some application might work, but some issues might be facing. So again they will resolve all these things, and again they'll check the dependencies and the libraries, the compatibility versions, and they will run it on the production or maybe pre-prod. So this was the previous scenario. So now once virtualization came into the picture, when the virtualization came, so what is virtualization? So here what we can do virtualization. So here we'll have an hardware and operating system, and then hypervisor, right? So multiple layers will be there. But now without installing operating system also, on bare metal we can install hypervisor. But previously uh, we used to have hardware, operating system compulsory, Windows operating system. So hardware, and this is an OS, any bare metal OS, and then this is an hypervisor. So virtualization, VMware or maybe Hyper-V from the Microsoft. And then here we used to install virtual machines. We used to create a virtual machines. So the advantage of this virtual machine, what we can do. So here, this development team can give the complete image. So once they are doing testing here inside this machine, they develop this application, and they can take the image, and this complete image can be given to the testing team, right? So when they're giving this to the testing team no need to install any dependencies, nothing, because this image contains everything, because you are giving along with the operating system. In the previous scenario, you were not giving the operating system. So operating system might contain some configuration might be some dependencies that you might not giving here. Only you are giving Java, this application converted into a jar file, and that they are going to test it by installing some libraries dependencies. But you are not giving the operating system, because you are not, for example, this is a Windows machine. You are not going to give your C drive to them to go and test it. So, but here, once virtualization came into the picture, we can take the image, these guys can take the image which contains along with the operating system. So whatever the prerequisite softwares, libraries, everything is running with that image. So they will just use the image and they'll create some instance, okay, virtual machine, and they'll do the testing. If anything finds a problem with the logic in the code level, again they will tell the developer teams, and again they will do the modification coding level, and again they will give the new image, and these guys will use the new image. Finally, if everything is okay, the same image will be run on the operations. Okay, and once it is working fine here, the same image we can use it to the prod environment also. Okay, this is how it resolves the majority of the issue. But if everything is resolved the problem here, then why we need Docker? Okay, why we need containers? Okay, so this is very good for the legacy applications. Legacy applications means what? Monolithic applications. Now, maximum companies are changing their application into monolithic application to the microservices. Can anyone have idea what is microservice? Anyone from the developer background or testing background? What is monolithic application and what is microservices?
Yeah, monolithic is a combination of several applications like billing, payments, and everything combined. But whereas if you divide it into individual components, so it is a decoupling of the total software. So that will help. If one is down, probably the rest of the system will continue.
Exactly. Okay. So whatever Ganesh said is 100% correct. Like for example, to run a website. Let's say if I take any a website, or maybe let's say if you take Uber app. Okay. So Uber app contains many features, right? Like previously, this is an application like used to have, like monolithic application used to have all the code will be available inside this one. Okay, and whenever they want to deploy, they'll deploy it on a server, on a physical server, maybe on its a virtual machine. Okay, so now, but before virtual machine concept, like application used to run on multiple machines. So single application to work it should have multiple servers or maybe single server. So any changes has been done. Like for example, we have Uber Go, Uber Ride, like Uber Bike, Uber Rental, Uber Pull, something like this. So altogether is like a single application. Any changes, developers will do the changes to this specific feature. Then to run this, we need to deploy all application into the servers whenever we are deploying it all together, the complete combination of all these applications. And for this, whenever, for example, only Uber Go is maybe Uber Pool, lot of requests are coming. So what we need to do, we need to have another server so that the load can be transferred. So again, this some complete application we should run on this specific machine. So to run on this specific machine, again, this all applications should be run here, all the services. But the request is coming, only huge traffic is coming to this specific option called Uber Pool. But to share the traffic, the complete application should be run on the another server also for high availability purpose. Then this application has been changed now, and they changed it to the modules. Okay, so what they were doing, instead of the complete single code, they divided as into the modules, the application developers. So this will be one module, this will be one module. So whenever they want to change the code, they will change the code only to that specific module. No need to change to the complete code. So that will reduce the time for the developers also. But even though that has been changed into the modules, but again they need to deploy all the application together on a single server. So instead of this, now why microservices came into the picture? So what they can do, so they can deploy only this specific application to the server, and this specific to this one, and this specific to another server. So like this, in a website, instead of full-fledged application, they would divided it as in separate microservices. Okay, basically this complete application is called as a service. So micro means small. So the complete application they divided into small services like microservices. So like that, it might be converted into 100 or maybe 50, 30 microservices. Why? Because the advantage is, if any problem with this microservice functioning over here, it will affect only this specific microservice. Maybe Uber pull might be not working. Remaining all will work because this is running as a separate application, separate microservice. So it will not have any problem. So this is individually working here, and it is not going to have it. If this is having problem in the code level or any problem, maybe huge load is coming and it's not able to perform, then this specific option will not work properly for the customers, front end users. Remaining microservices will work perfectly fine. Okay. And another thing is, to run this microservice, it doesn't require huge capacity. If complete application you are running, then it needs some CPU and RAM. But if it is divided into the microservice, so microservice doesn't require huge resources. So at least we can create a virtual machine with least capacity is 1 GB RAM and 1 CPU, right? But some scenarios in real time, microservice doesn't require even 1 CPU also. So in VMware, we can't give less than 1 CPU. Okay, I want 200 millicore CPUs or 400 millicore CPUs for my microservice. Then you cannot provide it. So in that scenario, the containers came into the picture to save the resources, and that is one reason. And another reason is, to run this microservice, each individual microservice need operating system. So if you're taking even for example enterprise operating systems, like even in Linux we have free open source, but if you are taking any enterprise operating system, then it is a Red Hat. If you are taking, you need to pay the license for support compulsory. So you need to have licensing for that, right? So instead of that, what we can do here, our containers are not going to use any operating system. I will explain you by showing the diagram. So that is the another reason why Docker came into the picture and why we are using here Docker, just because the applications are converting into the microservices. So if it is a Java application, so Java application will use a Spring and a Spring Boot framework to convert the Java monolithic application to the microservices, so that it will be running on different containers. Not, it doesn't require one full-fledged because to run the application, it doesn't require, when we are installing operating system inside a virtual machine, it will install all the unnecessary packages also. But to run this microservice, we don't require that much of operating system inside that. So to run that operating system in the VMware or any virtual machine, it will need at least some CPU and some RAM, and to run that services, backend services, lot of unnecessary OS services will be running. Okay, so we don't require all these things. So when Docker came into the picture, so you can create containers. Okay, so now let me show you the diagram. With the diagram, okay, if you see, this is the difference. If this is the virtual machine, this is hypervisor. It can be anything. It can be Hyper-V of Microsoft or VMware company, ESXi software, hypervisor. Okay, lot of hypervisor are there. For example, if you are taking AX operating system, there is a hypervisor called VIO. In the Linux, we have hypervisor called KVM. Lot of hypervisors are there. So famous are VMware and Hyper-V. So VMware might, I think most of you guys know about VMware. So you can take example of VMware here. And this is the container. Okay, so here, this infrastructure means hardware. On top of that, you are installing the hypervisor, and you are creating the guest operating systems, 3 virtual machines. So when you're creating virtual machine, what you're doing, you are taking the ISO image, and that ISO image is completely loading, and maybe 1 GB or 2 GB of the image content will be installed inside this machine. These are like each independent machines, and On top of that, you are going to install the dependent binaries or libraries to run your application. Whatever the libraries are required to run this application, framework, whatever it may be required. So you are going to install, and this machine is going to act like an independent machine. This one, and here we are installing operating system. Okay, so on top of that, we are going to install, this is called as a Docker engine. Okay, so we will install this Docker software which we call as a Docker engine. And here we are not we are not installing any operating system. We are creating a container which is going to use this base operating system. This is the base operating system and is going to use. And to spin up this container, to create this container, we don't require minutes or hours, because here virtual machine creation, at least it will take 30 minutes of time to install procedure. But here it will take not even 1 minute. Within seconds, this container gets created because we are not installing any operating system here. It is going to use this base operating system kernel. Okay, it is going to take the kernel. In the container, it will have some base image which contains 70 MB, 100 MB image it is going to have. But kernel, it is going kernel and remaining all the services, it is going to take it from here only to run this application. So it is going to take some base image that we'll discuss in the later on session. So creation will be very easy, and this container you can allocate like very less resources, as I said, millicore or maybe 100 MB, 200 MB to run that specific application. So each microservice is going to run on this specific container. So here in this container, whatever you want to run that specific microservice or application, you can have everything like binaries, framework, and any dependencies, packages is required in that container. Everything will be available. And this container, we can create an image, and that image can be used by anyone. The same scenario here, when we are talking like that container, if it is an image, and even testing as also can run nowadays in even in Windows 10. Also you can locally install Docker and you can test it. But in the real time enterprise organizations, they might be having some environment setup. On top of that, we can install deploy the Docker containers, and these guys can do the testing on that. So that image contains everything. We no need to separately install the packages inside that containers. Everything is ready with the dependencies. And the same image can be traveled to pre-prod, and the same image can be traveled to production. No need to do any changes because it contains OS and it contains libraries, packages. Everything is under one package. So if it is working fine in the pre-prod, the same image will be used over here. The same container image will be used here. So that is the major reason Docker came into the picture, because one is to save the resources. Here the container doesn't require huge resources, so whatever it require we can allocate them. And second thing is licensing. Here you are paying licensing for your VMware or maybe Hyper-V. So, but here you no need to pay any licensing. And second thing is spin up is very fast. So immediately it can be created, and immediately means within few seconds you can create it. Within few seconds you can delete it, right? And the another advantage is like, for example, I was talking when this Uber pool is getting lot of traffic, then this container, whatever it is running, let's say here it is the container is running. So no need to increase the capacity for all these microservices. So only this container, if you create one more container, the traffic is going to be divided to this both the containers. Okay. So this way it will work. No need to increase the capacity here. So previously when it was monolithic application, the complete application need to be run on another machine to get the traffic and to reduce the traffic. But now only this microservice container will be auto scale, so that the load will be shared to these both the pods or like both the containers, so that the traffic will be shared across these two only, because this is getting traffic. And as I said, another advantage, if the monolithic application is having problem, then it will impact to the complete application. Like if it is a website, it will impact to all the website. But here, if some option is not working, only that option is going to have problem. Okay, so remaining options inside that website or inside that app will function as it is. Got it? And the second feature is like it contains a Docker hub. So means you are going to get lot of images. Okay, so when we are talking about this Docker engine, so we have another concept called Docker hub. So actually Docker is a company. Okay, so they have both community edition and enterprise edition. Both will have the same features, only the difference is the support. Okay, so if you take community edition, then you will not get any support. If you take enterprise edition, you are going to get the support. So they have a Docker hub image repository where you are going to get a lot of images, predefined images. Like for example, if you guys want to configure Jenkins server, what you are going to do, you will create a one virtual machine, where it may be, whether it's on VMware or AWS. You will just first create virtual machine. You install Java prerequisite 1.8 version, and you install Jenkins from Jenkins repository, and you configure it, right? But Docker Hub will give you the image, container image, and that you can run it on maybe on your local. If you have Docker is installed inside your local laptop or on any machine, directly you can just start your Jenkins server within a second. So like that, so we have a lot of images available, like Redis image is there, Nginx image is there, RabbitMQ image is there, messaging queue, uh, MySQL, MariaDB, lot of softwares. You no need to configure anything. Okay, directly you are going to get with along with the prerequisites with very lightweighted images they are going to provide. So you can take those images and you can use it in the real time. As I said, these applications, whatever these applications will be there, that we are going to create the images in the coming sessions. We'll know how to create images for these applications, how to write a Docker file to create the images. All these things we'll discuss. So here, if you see, this is the Docker hub, and you can see any kind of images over here. Let's say if I want Jenkins. So here you can able to get, this is official image, means Jenkins are providing you the Docker images. Okay, so lot of software like this, individual persons also placing their images here. If you see 10 million downloads by this user also, and this is an official image. So it's very less size will be there, which can run on the Docker container. Okay, so here if you, the only thing is you need to have Docker should be run, whether it's on your local or whether it's on any machine. So you just, if you use Docker pull Jenkins, then automatically it will connect to this Docker hub and it will pull that image. And when we talk about the images at the time, I'll talk about the sizes of this one. Okay, so here anything, if you go to Nginx, lot of images are available which we can use in our organization instead of manually configuring everything. So this is another advantage with that Docker. And we have another containerization is also available in the market, which is called Docker Rocket D. Rocket D is also another container technology, but most of the organizations will use Docker only. Okay, so Rocket container is also there in the market. So maybe some organizations might be using it, but majority will be 95% will be everyone is using this Docker containers. So what we need to have, we need to create one virtual machine. I hope, as I said yesterday, you need to create one virtual machine in the AWS if you have AWS account. If you don't have AWS account, then create an AWS account. In our YouTube channel we have an video to how to create AWS account. You should have any credit card or debit card, so you should give those details. once you created, we can use a free tier account. Only for Docker, we are going to use it to practice it. Okay. If you have any other methods, like if you know good in Vagrant, okay, so you can use Vagrant in your local laptop and you can create virtual machine inside that. Or else simple way you want to go with, just create an account inside that AWS and then just create a virtual machine. It's very simple. Just go click next. Then you can able to create a machine. So let me create quickly one machine here. So in the meantime, just let me know if you have any doubts, queries.
Yeah, one quick question, Praveen. In the
Hmm.
monolithic application, you mentioned that multiple people can call. If at all I deploy that application onto the web, the whole world can call that. How does it work in case of a Docker? If I create an image and deploy that onto the web, and that Docker image need to be pulled as a container, and that need to be deployed on another VM.
No. So here that comes the Kubernetes or maybe Docker Swarm comes into the picture. So when the individual container is running, this all together will be connected to a application gateway. So that application gateway will be accessed from the external world. So whenever you are trying to access a URL, it will go to the application gateway. From application gateway, again, it will redirect to each individual microservice.
Okay, so thousands of people can use that application which is on a container.
Yes,
Okay, got you.
not
Thanks.
on container. Application gateway will be configured maybe in the cloud. In AWS, we have application gateway. In Azure, we have application gateway. So
Yeah,
there, what we are going to give, each microservice is going to configure with a load balancer, and that
yes,
load balancer details will be configured under the application gateway. So application gateway will route the traffic to independent internal load balancers of the microservices.
yeah, yep. That part I got it. Thank you.
So let me create one virtual machine.
I have a question. So can you open that image, a VM and the Docker image from Google, which you opened?
This one, right?
Yeah, yeah. So, I mean, you told like in the first image, okay, so this VM, so application one, two, three, all these three things are independent of each other. The left side, VM.
Hmm. Yeah.
Application one, application two, all these three applications, they are independent of each other. It means isolation, right?
Hmm.
So similarly, Docker is also providing the same thing. Application
Yes.
one, two, three, all these things are independent of each other, isolation. So what is the major difference?
Yes.
Is it only the size of the application, or is there any other like important difference?
Okay.
Because both the
So
things
as
are
I
providing
said,
it.
if the application is converted into a microservice, if that microservice want to run on this VM, so to create this VM to spin up, it is taking time. And the second thing is it is utilizing lot of resources, CPU and RAM storage. It is wasting here. Okay, but here it is not wasting any resources here. Whatever you want, even millicore CPUs you can give. And second thing is it is not installed with the operating system. It is using the base operating system from here. Okay, so it is not going to get any performance issues. Very quick and fast it will be there. And here it contains operating system services are running and it need minimum resources. And the scale up also will take time, but here scale up will not take time. And second thing is here you are using hypervisor which is a licensed, and here also to run that microservices here in real time, if you are installing the operating system, means you need to buy the entitlement of that operating system. So if you are using Red Hat Linux, then Red Hat Linux, you're not going to get it free, you need to pay license for that. So these many microservices to run, you are installing the operating system in each and every virtual machine, which you need to pay the licensing. But here, you are not installing the operating system. You are using this base operating system. Okay. So let me show you another way, like how it will work. So basically, this is one container and this is another container. This is another container. Let's say this is a CentOS container, and this is Ubuntu, and this is uh, assume Red Hat. We don't get Red Hat, but just I'm giving some Linux flavors. Okay, so instead of this one, let me give Debian. Okay, and here the operating system, like this is an hardware assume, and this is an operating system. And this operating system assume this is a CentOS. In the CentOS, you install the Docker engine. So here, how Ubuntu, this container is Ubuntu, this container is Debian, this container is Fedora. So you are going to get some base images of Ubuntu, which contains 70 MB or 60 MB of size. Debian 40 MB or 50 MB or maybe less than 100 MB of size. These images will be available providing by the Docker. So it doesn't contain kernel and binaries. So everything is going in the Linux. We have 367 flavors of Linux. So all the flavors can use the same kernel here. So this container is going to use kernel of this machine. This container is also using kernel and binaries, everything from here. So this is only to start up. It is using some base image, which is a very tiny size, around 60 MB to 100 MB size. This Ubuntu image is providing by the Docker. Okay, and the same way, this is also Debian image we are going to get, Fedora image we are going to get. But end of the day, these are taking the image from here. Okay, kernel, the binaries, because Linux flavor will support all this, kernel will support to the all the flavors. Okay, so that's why it is, whenever it is running, it is not going to have its own kernel. So it is going to take the kernel from this base image. So here, when we are creating container, we will just give the image. Okay, to run this application, which flavor is compatible to that application, that image we are going to get from the Docker, whether it compatible with Ubuntu or Debian or CentOS, Fedora, whatever it may be in the Linux flavor. On whichever machine it works perfectly, that image we are going to get the tiny image. But remaining kernel, binaries, everything is going to take it from here. So here you are not going to pay anything to the vendor for licensing entitlement. Okay, so that is a advantage.
So does it support Windows platform containers?
They have started, but I think no one is using Docker for Windows. It will be very good for Linux only.
Okay, okay.
So
Thank you.
basically, I think just a quick 2 points here. Whenever you look
Hmm.
this application one, application two, application three on both sides, these are three. You look them as three different applications. If you look at the
Yeah.
bigger picture, if you deploy web services, there is something called service mesh, which will be used to connect all these microservices. So the real advantage of Docker or Kubernetes comes into picture when it is orchestrated. So that orchestration will give much more benefits uh, in the longer run or bigger picture.
Yeah, that already for these guys I explained yesterday about this advantage. Like we can do auto scaling quickly. Immediately we can scale up. Okay, and load balancing. So when Kubernetes is doing orchestration of these containers, so many advantages we are going to get instead of running it on a normal virtual machines. Okay,
Virtual machine.
so that you guys can slowly understand when we start completing this Docker and Kubernetes, then you can compare how they were running on the virtual machines and how they are running on the Docker with managing Kubernetes orchestrator. So what advantages we are going to get. So slowly you'll come to know about that. Okay.
Okay, yeah. No, I don't remember the name of the person who asked you the question. The question was, what advantage do we get? Only the lighter weight or the sharing of the beneath underlying operating system? When you compare in that perspective, that's the minimal advantage we get. The bigger advantage comes in when we use the orchestration part. That's what.
Yep.
Okay, got it, got it. Thank you.
Praveen, one question.
Yeah.
Yeah. Actually, what about the security for containers? Like we will be installing patches, right, for VMs. So how about for these containers?
Mm.
So
Security, you mean to say OS level security or?
no, for containers. Like if we have a Jenkins image, there can be some
Mm.
uh, unknown calls, right? I mean, there can be content data which can
See,
increase the traffic.
yeah, that will be come to know when we start about Kubernetes, because these containers will be accessing only internal. Okay, it cannot be accessed from the external world. So that's why it will not get any traffic from the external world, and the ports whatever is also accessible. It's only internally it will be accessible, not from the external world. So we don't need to worry about if some hacker is going to attack to our containers. Okay. So if there are any loopholes in the Kubernetes cluster software, then they can come and attack into the cluster. And for that also, a lot of tools are available to scan the vulnerabilities of our cluster, and we can fix it as an administrator. Okay. So that part, when we start about Kubernetes, then I will tell you how to manage these containers securely.
Thanks, Praveen. Yeah.
Okay, so let me quickly launch instance, and this is not about AWS class, so I'm not going to tell you the options. Just I will show you just options what we need to select. Just click and create an instance, and that you can get in YouTube also, like creating of instances also. So here you can select any image. I'm going to select the second image, select this one, and D2.micro is free tier. We can use a free tier. And here don't change anything here in this option, third option. Just select add storage, and here also don't change anything. If you want to give any name, tag name to your machine, you can give it. I will give this as an Docker server. And security group, here also don't change anything, and then launch. And here you need to create a key pair, because AWS will not allow you to log in with the username and password. So you need to select key based authentication. So select create a new pair, and give any name to your key and download. So this is like a public and private key authentication. The server contains public key, and it will ask us to download the private key. So we'll save it and log.
Praveen, which image you took? Amazon Linux or Amazon Linux type?
Amazon Linux, second one.
Amazon Linux. Okay.
Yeah. So view instance, it will be online within a minute. So let me filter it. Instance state running. So you need to use a mobile XTerm tool to connect the Linux machines. Those who are new to Linux, you should be good in the Linux, because if you want to become DevOps engineer or machine learning, Hadoop, anything nowadays compulsory is Linux. Okay, so try to learn Linux if you, those who guys don't have knowledge on Linux. So we are going to use mobile XTerm tool. Previously, we used to have a Putty tool, but in the mobile XTerm tool, we have a lot of features. So we can use this tool to connect the Linux machine. Okay. So now I think machine is up. Okay, it's up. Just copy the IP address, select it, copy the public IP, and session SSH. We are going to establish SSH connection to the server. So here by default, AWS will give you a user account called EC2-user to connect the machines. So use it and select here the private key I created with the desktop. This is the docker.pym. So it's created, and this is one of the Linux machine, and here we can install the Docker. Okay. So what I'm going to do, just type yum install Docker. It is going to install, and if you see here, this is CE Community Edition. It is going to install. So you can just press yes to install it, and whatever the dependencies it is required, it is getting installed. Okay, so just remember this picture when you guys are installing. Just take the screenshot. We are going to talk about this containerd and runc also, because this is Docker engine. We call it an engine. Inside this engine, multiple parts will be there. So one is runc, and this is a containerd. So all the containers are going to manage by this containerd service. Okay, and once it is done, just service Docker status. It is in stop state. Just start it. It is started. Now you can check for the first command is docker ps to see any existing containers are created. So from Monday onwards, we are going to talk about the Docker topics, how to create containers, and how to create volumes, how to create Docker network. Okay, what is Docker file? All these things we'll discuss. Okay, if you have any doubts in today's session, just please go ahead and ask me, or else we'll wind up for today's session.
What was the command you fired for the Docker installation? I missed that.
Yum install Docker. This is the one.
Okay. And this version is 19 or 18?
It's 19.
Thank you.